Hey guys, what we're going to work on today is again some geometry and some heavy vocabulary with geometry, but we're going to focus on this word, and this word is hierarchy. And a hierarchy is putting things into the categories that they belong to, but kind of making a flow chart of sorts where you see something that it's almost like who's in charge, right? So at a school, we have a hierarchy. At a school, you have a school board who is ultimately in charge. And then that school board tells the superintendent what to do. The superintendent tells the principals what to do. The principal tells the teachers what to do. And then the teachers tell the students what to do, right? I tell you what to do all the time. Hopefully I'm usually nice about it. How about, since we're talking about teachers and schools and all that, why don't you write EILMS in the bottom right-hand corner of your paper so that I know that you are watching this. So we're going to use the word hierarchy, but we're going to think about it with shapes, right? So whenever we think about shapes, one of the first things with two-dimensional shapes that we look at is polygons. Okay. Now there are some typical shapes that are not polygons, that would not even go into this. And so a circle, oh, that's more like an oval, and a circle. Ovals and circles are not polygons. So they're just kind of different. They're rounded edges. We do not work with those right now in terms of what we're doing. But all of the other shapes with straight edges with closed sides are polygons. So we've got polygons, and then after polygons, we usually are going to split it into triangles, into quadrilaterals, and then maybe into others, which others might be a hexagon, an octagon, a decagon, different things like that. Within triangles, I told you we can categorize them by their sides and their angles. So within triangles, we can do the three different types of angle measures. So we can say acute, obtuse, or right. And then within those, we also can do the side lengths. So an acute triangle could be an equilateral triangle, or it could be a isosceles triangle. It really couldn't be a scalene triangle, because a scalene triangle is probably going to have some different features, okay? An obtuse triangle could not be equilateral. It could be isosceles, and it could be a right triangle. And then, isosceles or scalene. A right triangle could be, it's really going to be scalene. So we kind of take a hierarchy. Here are some shapes. They're a polygon. Oh, it's a polygon, but it's also a triangle. It's a triangle, but it's also an acute triangle. It's an acute triangle, but it's also an equilateral triangle. So when we get down to these are like the most specific shapes when you get down to here. Because we can say it's this, it's this, it's this, it's this. Have you ever heard people say that a square is a rectangle? And sometimes people want to argue that and say, no, it's not, no, it's not. Well, sure it is. A square is a rectangle, and let me show you how. I'm going to get a different paper because this one's a little full. So within polygons, right, we've got polygons, and then we could go to quadrilaterals. And one of the things that I told you with quadrilaterals, being four sides, is we could do parallelogram or non-parallelogram. Parallelograms have two pairs of parallel sides. And so within a parallelogram, we've got some different ideas. We can do just a regular parallelogram. We can do a rhombus. And we can do a rectangle. Well, a rhombus means that it's got four congruent sides, four sides that are the same. Is a square a rhombus? Sure is. Is a square a rectangle? Yes, it is, because it has four right angles and it has four congruent sides. So when you think about a square, yes, a square is a rectangle. It's a more specific rectangle, okay? When we go into non-parallelograms, typically we're going to look at kites and trapezoids. because those would be the two kinds of quadrilaterals that would not fall over here, okay? Sometimes we've got funky shapes too that might be a quadrilateral and it's a non-parallelogram. You know, if you have something like this, well, that actually is a trapezoid. I'd have to make it a little bit more like that, okay? So this shape right here has 4 sides, but it's not a kite and it's not a trapezoid, okay? So those will be our quadrilaterals. And then again, we've got polygons, and we can do an other category where we might have an octagon, we might have a hexagon, okay? And we might have a decagon and different things like that. Octagon 8, hexagon 6, decagon 10 sides. So being able to take shapes and put them into a hierarchy is the fancy term, but really it's like a flow chart, right? So how would we think about the attributes of the shapes or the properties of the shapes, and then how could we categorize them and put them in into the different categories and the hierarchy? What is generic? Polygon's generic. We can get more specific. We can get more specific with our polygons, and we can say, okay, I'm gonna take my polygon, I'm gonna put it into 3 different categories: triangles, quadrilaterals, or others. And then once you go into triangles, you can get more specific. Once you go into quadrilaterals, you can get more specific. And once you go into others, whoops, you can get more specific as well. So that is how we might look at a hierarchy of shapes, putting them in order of their attributes, but one is this, this is this, this is this. So in that, you know, big question that people often say, is a square a rectangle? Yes. Is a rectangle a square? No. A rectangle is not a square, because a rectangle doesn't have 4 congruent sides like a square does. So that can be a little confusing, but that's what we're working on here with our hierarchy of shapes. Thanks for watching.